Hey, welcome! Have you ever stopped to think about the number zero? I don't mean just nothing, but as maybe one of the most powerful inventions in all of human history. Today, we're diving into the incredible origin story of the numbers we use every single day. And believe it or not, it's a journey that starts with a simple question about rice and ends with us being able to count the entire universe.
So our story kicks off with this really simple, relatable question about rice. A young boy finds out there are about 100,000 varieties in his country, and he just wonders, could you even taste them all in one lifetime? It's such a great question because it gets right to the heart of a fundamental human problem. How do we even get our heads around really, really big numbers?
And this is it, 100,000. This is the number that started it all. We see numbers like this constantly, but just pause for a second and think about it. The fact that we can write this down so cleanly with just 6 little symbols is an absolutely stunning achievement. It's the final product of an intellectual journey that took thousands of years to figure out.
You know, the need to count is basically as old as we are. And this wasn't for some academic exercise. It was born from real-world practical problems. How do you measure a plot of land after a river floods? How many soldiers are in your army? Or, let's go way back to 3000 BCE, how did the Indus Valley civilization make sure that every single brick used to build their massive cities had the exact same 42-to-1 ratio for maximum strength? They had to count, and they had to be precise.
And this right here was the first giant hurdle, notation. I mean, it's one thing for a shepherd to count his flock using a little pile of pebbles, but how does he record that number? How do you turn a physical amount into a symbol that someone else, maybe miles away, can read and understand, especially when the numbers get way bigger than your fingers and toes?
Okay, so lots of different civilizations took a crack at this. The Egyptians had their hieroglyphs, the Mesopotamians had their cuneiform, and they were all pretty clever. But let's be honest, they were also really clumsy. One of the most famous of these early attempts, of course, belongs to the Romans.
I mean, just look at the difference here. On the left, a pretty simple addition problem with Roman numerals. It's just a confusing mess of symbols that you have to kind of translate in your head. But on the right, using the system we all use today, the exact same calculation is clean, simple, and intuitive. The difference in efficiency is just night and day. So what was the secret ingredient? What were the Romans missing?
Well, the answer was a monumental innovation that came out of ancient India. It was a concept so powerful that it would eventually spread across the entire globe and become the engine for science, for commerce, and for pretty much all of modern technology.
So the first piece of the puzzle was this genius idea called the place value system. Instead of inventing endless new symbols for bigger and bigger numbers, the position of a digit tells you its value. Is it in the ones place, the tens, the hundreds? It's an incredibly efficient idea. But this powerful new system had one critical, gaping hole in it.
And this was the big puzzle. If a place is empty, what do? How do you write down the difference between 52 and 502? If you just write down 52, how is anyone supposed to know you mean there's nothing in the tens place? Without a way to mark that empty column, the whole system just gets really ambiguous and falls apart.
And the solution, of course, was the invention of zero. But here is the absolute game changer. It wasn't just a placeholder. Thinkers in India, like Brahmagupta around 628 CE, started treating zero as a number in its own right, a number with its own rules for addition and subtraction. That one idea completed the system and unlocked a level of mathematical power the world had never ever seen before.
And this system, we often call it the Hindu-Arabic system because it was transmitted to Europe through the Arab world, was just plain better than anything else. It was so powerful and so efficient that it slowly but surely replaced every other counting system on the planet. And even though Europe was pretty slow to adopt it, this new math would eventually become the fuel for the entire scientific revolution.
So, armed with this amazing new tool for calculation, humanity could suddenly start to explore and describe concepts that were basically out of reach before, especially the mind-bending power of exponential growth.
Just think about folding a piece of paper. It seems so simple, right? But the growth is exponential. Fold a single sheet of paper just 26 times, and its thickness would tower over the tallest building in the world, the Burj Khalifa. Get this, make it 30 folds, and you've reached the cruising altitude of a jet airplane. Our number system is what makes this kind of explosive, multiplicative growth so easy for us to calculate and understand.
And that's really the difference in a nutshell. Linear growth is additive. You're just adding one step at a time. It's a steady climb. But exponential growth is multiplicative. You're multiplying. It starts out slow, and then all of a sudden, it just explodes upwards.
This newfound power to handle both the absolutely massive and the incredibly minuscule gave us a whole new language to describe reality itself: scientific notation. Suddenly, we could talk about the distance to the farthest stars and the size of a single atom using the very same elegant system.
So when you look back, this whole journey wasn't really just about inventing numbers. It was about creating a truly universal language, a system of logic and description that is the foundation for our entire modern world.
And this language is absolutely everywhere. It's in the ratios we use to build our houses and to bake a cake. It's in the coordinates that your phone uses to navigate the globe. It's in the pure logic we use to build a sound argument. And yeah, it's in the scientific notation we use to describe the mass of our own planet. At the very heart of this language are foundational truths, what we call axioms. Statements like this one from the Greek mathematician Euclid seem like just obvious common sense, right? The whole is greater than the part. But by agreeing on these basic truths, we can build these incredibly complex and rigorous systems of logic and proof that are understood by everyone, everywhere.
When you really step back and look at it, the journey from just scratching tally marks on a bone to developing a system with place value in zero, well, it's arguably one of the greatest inventions in all of human history. This isn't just about numbers. It's about our species creating a language to reason, to build, and to understand reality itself.
And all of this leaves us with one final, totally fascinating question to ponder. If this beautiful, intricate language of mathematics is a purely human invention, something we made up, then why is it so unreasonably, so perfectly effective at describing the fundamental laws of the universe? Was math discovered, or was it invented? Now that's something to think about. Thanks for joining us for this explainer.